Hello. Hello Sandeep, can you hear me?
Yes, ma'am. Yes, ma'am.
Okay, chalo. So good evening everyone. I'm Shruti. I'm the PMRF TA for this NPTEL course Symmetry in Group Theory taken by Professor Anindya Datta. So today we are discussing. This is our third live session, and we will be discussing assignment number 2. So I know Sandeep. He was there in the last session, and that there's a new student, Love Kumar Bhagat. Can you introduce yourself? Oh, he left the meeting. Okay, so I was waiting for a few students to join. He joined again. Now, where are you? Hello. Are you there in the meeting? How many sessions have you watched? Sandeep, did you solve second week assignment? Did you submit it?
Yes, ma'am. I submitted, but I have one doubt in question number one.
Question
Number
number
one is
one.
there, na?
Okay.
Yes.
Okay, so let's start. Okay. This question?
Yes, ma'am.
Okay. I'll turn off my video. It takes so much of internet. So, why do you have doubt in this one? This was discussed in the course, right, Sandeep? Didn't you watch?
Yes, ma'am. It was discussed.
Huh?
So I was writing that I was writing then, but in the course it was z-axis. But here
Yes.
the axis of rotation is y-axis.
Huh.
So if we are taking the cyclic rotation now, so when we are rotating about z-axis, then we are getting matrix like cos theta, then sin theta,
Hmm.
then
Okay.
0
Zero.
cos theta sin
Yes.
theta 0,
Yes.
then minus sin theta,
Huh.
cos theta,
Zero.
then 0, then 0 0 1.
Yes.
So
Yes.
this matrix comes in the case of z-axis rotation.
Yes.
And as we know that the all three axes are we cannot change
Orthogonal.
the yes, orthogonal. And after x, y should come, and after y only z should come.
After
And
x, y should come. Okay.
after y z should come, and after z x should come.
Okay. Yes.
So if we are rotating about z axis,
Hmm.
then whatever effect we were getting in terms of cos theta and sin theta, that matrix,
Hmm.
the same effect should repeat when uh,
Yes, yes, I
we are
got your
actually
point. I
rotating with
got your
respect to it.
point.
Yes, ma'am.
The effect
Yes,
will
ma'am.
be same, but the matrix
Yes,
will
ma'am.
change because
Yes, matrix
matrix
will
will
change.
change. Yes.
So whatever was when we were rotating about z axis, then after z the next axis was x axis.
Yes.
As per the cyclic rotation,
Okay.
after z the axis was the after z the axis would be x axis.
Yes.
So when we are rotating about y axis,
Hmm.
then the whatever had happened to our x axis,
Okay.
this should happen to our z axis.
Yeah. You can simply when we were rotating about z axis, we were taking the planes at x and y.
Yes, ma'am. Yes, ma'am.
Yes, the
But
plane was
but
x and y, so you
but
can simply replace
yes,
it
ma'am.
by y and z.
No, ma'am. Actually, the sign will change now because we cannot rotate. Because when we are rotating from x axis to y axis, when we are moving along x to y, then it should be then rotation of x to y should give the direction of z, because all are orthogonal.
Okay, you are
So
but here it is not written that first you are rotating along the z axis, then you are it is the only one question that you are applying and rotation by angle theta around y axis itself. It is not considering whatever the previous rotations you have done.
No, ma'am, it is previous rotation is not required
Huh?
because as we know now, this
Okay, okay.
x
Let
axis,
me
y
let
axis,
me
and z
when
axis. Yes,
how
ma'am.
you draw the 3D Cartesian coordinate like this. Oh, sorry. This we mostly write z. This we write as x, and this we write as y. Okay.
Yes, ma'am.
So in the course, it was rotation along z-axis. So what plane
Yes,
we
ma'am.
took? The down one, the xy plane,
Yes,
isn't it? We took this plane.
yes, ma'am.
So we took
Yes, ma'am.
one position coordinate here, one here. Now
Yes, ma'am.
we have to take rotation around this. So we will take this plane, this plane. Other things are same. We have to take this plane because we have to rotate along this. So
Yes, ma'am.
one position vector before transformation we will take here, and the other one we will take here. Like after rotation, it will come here.
Ma'am, if you can write that now,
I'll write. I'll
that
write.
Good evening,
that
madam. Previously, we couldn't respond your questions. Sorry for that.
Okay.
And
Oh,
again, I am.
okay. Yeah, it's
Yes,
okay.
ma'am.
It's fine. It's fine. So, did you solve second week assignment?
Yes, madam.
Okay. Where are you from?
I am from Jamshedpur.
Okay, okay. And what are you studying? Are you in masters or what? Did you complete?
I, I have completed my MSc from Central University of Jharkhand.
Okay, great, great, nice. Okay.
Thank you.
So did you watch like week 3 up to week 3 and week 4 has been uploaded, right?
Yes, madam.
Okay.
And
You are joining for the first time, right?
yes, madam.
Okay, okay. Did you watch recordings? We have uploaded the recordings from previous sessions. Or do you have
No,
any doubt?
madam. That I have not watched.
Okay, it's fine. It's fine. You can just follow along this one. So we are discussing
Okay.
second week assignment. The deadline was on 9th August. The deadline has been passed. So we are discussing the answers now.
Okay.
Yeah. You can mute yourself if not needed.
Okay, ma'am. I am trying, but it did not work. That's why.
Okay. Okay then. So what I will do, Sandeep, here, uh, I will just, instead of writing this, I can write like this. Just I am changing the
ma'am,
axis, other things will remain same. Okay. So if I take one position vector here before transformation and let it coordinate be x1 z1, the other one after theta degree rotation be it here, its
ma'am,
coordinate be,
ma'am,
yes,
where is z axis?
this one is the
Actually,
z.
where is y axis? Y axis.
It doesn't matter now, we are rotating.
No, no, it matters, madam, because now because as we know that
Okay,
I
you
cross
want me
k,
to flip the axes,
yes,
right? Okay, no
yes,
problem.
I
Okay, fine.
cross k should give the I cross k should give
Yes, I got your point.
minus j,
Yes,
or
okay.
some I cross j should give k, because those are that cross product should be maintained now, because these are the unit vectors and we are doing the cross product, so those should be maintained. We
They have
cannot.
not mentioned it as a as unit vector, but okay, I will take it. Okay, this one you want me to write, right?
Uh, this uh, yes, ma'am. Yes, ma'am.
Okay,
Okay, ma'am.
okay. So so still this is positive z or negative z? This is positive z,
This
right?
is for, yes, ma'am.
This
Positive.
is positive. So can you
Ma'am.
think the answer won't change if I'll write up or down? And x is positive x this side, right?
Yes, ma'am. Yes, ma'am.
Okay, so let me write, before transformation I have a position vector here. Let the coordinate be x1 z1, and it has a length of L. Okay, and here my axis is somewhere here around this circle. This circle represents my y axis, which is facing towards you. Okay, so if I am rotating
Yes.
it along this, so it will go somewhere here by an angle
No, ma'am.
theta.
No, ma'am. The rotation is clockwise. Clockwise.
Okay, fine. Is it mentioned clockwise?
Yes, ma'am. It is mentioned. It is mentioned.
Okay, fine. Then it will go here. So this one is actually, when is it mentioned? Let me see once. Okay, clockwise rotation. Fine. It is x2, this is z2. Now as it was done in the course, we will try to do that, and let's see if we'll end up in the same answer. I did the other way, the way which I was showing you in the first slide now. I did like that. So this angle we will take it as alpha. This angle will be theta minus alpha. Okay. So
We are taking angle with
and
angle with.
previous angle, which was the original angle, we are taking it as alpha, because this is the
Alpha,
rotation.
alpha should be, if we are taking alpha, then it should be, we are measuring angle in the anti-clockwise direction, so it should be alpha is okay, but
This is
when we are measuring.
this whole thing is theta.
Yes,
So up to from here to here. Anyway, if you want me to take this angle, but how we will take this one then?
it is okay, ma'am. It is okay, ma'am. But for theta minus alpha angle,
Yes.
whole angle is theta. So theta minus alpha is the magnitude. But as we are going down from the axis, then the angle will be sign should come
Yes,
negative.
that
Because
will be taken care by the this x2 z2 signs. You got my point.
uh,
Since
ma'am, actually, that will be taken care if we are taking theta minus alpha minus theta. Earlier angle was alpha. When we rotated, then the alpha got decreased. So it should be alpha minus theta. Earlier the angle was alpha, but
this whole rotation is theta.
whole rotation is theta, but earlier angle was alpha. So
Okay.
alpha has been decreased. Alpha has got decreased by theta angle. So it should be alpha minus theta.
ठीक है. Okay, let me try your way. Let's see if we reach the same answer or not. This is alpha minus theta. Okay.
Yes.
Now what will be, we have to write cos of this one. Actually x2, this one, it is negative, right? So I think the angles will be taken care by the negative sign of x2. Okay, let's see. Now for this one, for x1 is how much? This is x1, this point is x1. How much it will be? Sine?
x1 is r sine alpha.
Yes, x1 is L, I have taken L, okay, L sine alpha. And z1?
and yes, ma'am. This one
Cos?
is R cos alpha, L
Yes.
cos alpha.
Okay. Now x2.
Uh,
X2 is will be this one.
yes, ma'am. So X2
So
is
this one. So it will be sine. Okay.
yes, ma'am. Yes, ma'am.
L sine alpha minus theta. So let me ask someone else. Is love here? What will be the
Yes, madam.
expansion? What will be the expansion for this one?
L sine minus alpha, na? The sine theta, sine alpha sine theta plus sine theta cos alpha and cos theta sine alpha.
For sine it is cos, right?
और इसमें ज़्यादा तो परेशान होने वाला कोई बात है नहीं, क्योंकि ये जो है मैथमेटिकल पूरा डेरिवेशन है, इसको मैंने कंप्लीटली सी एक्स सी वाई सी जेड तीनों के लिए डिराइव किया था। तो
Okay.
ये जो है कंप्लीटली जैसे जैसे वाई के रेस्पेक्ट में अगर हम लोग इसको कर रहे हैं तो वाई को छोड़ दीजिए, सीधा एक्स जेड को लीजिए और कीजिए, इजीली सॉल्व हो जाता है। और लास्ट में वाई है तो वाई इक्वल टू वाई टू लिख देंगे और ये सॉल्व हो जाता है। इसमें कुछ
Okay, but
ज़्यादा
Sandeep
प्रॉब्लम
is
नहीं है।
asking doubt about the direction of the coordinates we are taking. Can you comment on that?
Actually, Mr. Sandeep, can you please repeat your question? What problem you have in this question?
Actually, when we are writing now that rotation matrix about z-axis,
हाँ, ठीक है।
then then whatever we are writing, we can simply interpolate that. We can simply use that matrix to write any rotation about y-axis. But while using that rotation, uh, because when we rotated about z-axis, then after z-axis it came x-axis. So similarly, we have to do the interpolation when we are rotating about y-axis. Then whatever happened to our x-axis earlier, now it should happen to z-axis. So in that way, if we are writing, then none of the answer was matching. That's why I have confusion in this question.
Now
So it is
also
okay
it
that
will
madam
not
is
match.
doing.
See. Now also it will not match. We got cos theta minus sine theta for x2, which should not be the case. And even if I'll write at L as a minus of L, then this will be minus, this will be plus. We will write here minus, then still I am getting minus cos theta plus sine theta.
Mr. Sandeep, do you need the derivation of this thing? So if you give me your WhatsApp number, I can send you the click of photo.
No, because
You can,
it is
if you
required
want,
now. It is
if you want, you guys can discuss in the discussion forum. There is a
no, it
discussion
is
forum.
it is. But here also we are not getting, ma'am, now.
Yes, here also we will not get, because actually you have changed the direction. You have changed the direction of the axis. That's
because
why.
because axes are fixed, we are the direction of positive x-axis, positive y-axis, and positive z-axis. They are orthogonal, and I cross j must give k vector. We cannot change the that orthogonal coordinate system. No? So that's why.
Whatever.
Ma'am, if you can write now, if in the next slide, if you are writing now, I will tell how I did it and how I was not getting. So,
Isn't this correct? I always write xy like this.
no, ma'am, it will not be, because we have to move from you right hand thumb rule. You go from x axis to y axis. It should give the direction of z axis. As we are moving our
Okay, you want like this.
yes, ma'am, it is okay. X to y, the movement of x direction to y direction,
Okay.
it should give the direction of z axis. It is the right hand screw rule or thumb rule.
Okay. Okay, fine. Now is it correct?
Now it is correct that y-axis will be perpendicular to the plane above. When we are moving from z to x-axis, then it will give the
Yes,
positive direction of
I
y-axis.
think it is correct now.
Yes, ma'am.
Yeah. Okay, let's see then. Again, we'll try. This one initially we were taking the angle.
And when we are taking angle with the axis, then the anti-clockwise direction is positive angle. So if we are taking angle with z-axis,
Z
then
axis we will have to
anti-clockwise.
take because they have shown like clockwise rotation, right? So it will go
Yes.
here. So we have to take this complete angle with as theta.
No, no. It will go. It will come in downward direction, ma'am. Because the
Isn't this
y-axis is
clockwise?
perpendicular. Yes, ma'am. Yes, ma'am. Yes, ma'am. It is okay, ma'am. Okay, ma'am.
This is okay, right? It is clockwise.
Okay, ma'am. Yes, ma'am.
Okay.
Okay.
Now this angle is alpha and this angle is theta minus alpha.
Here sign has changed, ma'am. Sign has changed because we are measuring angle with anti-clockwise direction because from the x-axis. So if we are measuring angle from the z-axis,
Oh, you
then
then let me write this as a minus alpha.
uh,
You want me to write? You want me to
or
measure the angle with respect to z axis, right? If I'll write this minus alpha, then this will be theta plus alpha.
or ma'am, we can make those two position vector
Hmm?
within the uh, xz quadrant itself. Those two position vector,
Within
we
the
are changing
quadrant.
the quadrant.
Okay.
Yes, entire we can make in the same quadrant. So in that case also sign will be theta minus that alpha minus theta. So if we are making in the same quadrant itself, then the value should come same.
So this is y x1 z1. This is x2 z2. Okay. Now
Is it anti-clockwise direction? No?
Yes, ma'am.
this is clockwise, right? From
Clockwise.
here
Acha,
to here.
clockwise.
This is clockwise. Now clockwise theta. So this is theta.
Yes, ma'am.
And this whole, let us take this one, we will take it as alpha.
No, ma'am.
Minus
X1
alpha.
that no no the entire angle that for x1 z1 the initial angle was alpha.
Okay, you want me to
X1
take this one
yes,
as
alpha.
alpha. So this
Yes,
angle will come as alpha minus
theta.
theta. Okay.
Yes, yes, ma'am.
Now x1 is
X1 is L sin theta.
this one.
X1 is L sin alpha.
This is what will be this angle will be?
Uh, that angle will be 90 minus alpha. 90 minus alpha. So
90 min, oh, this is whole is alpha. Okay, 90
alpha.
minus alpha.
Alpha.
So
So it will
x1 is
be
this one. So x1
x1
will
will
be
be
cos.
cos cos L cos 90 minus alpha. So
Yes,
it will be L sin alpha.
L cos 90 minus alpha. L sin alpha, and z1 will be L cos alpha.
Yes, ma'am. Yes.
Okay. Now x2. Now x2 will be, let me put it to 1 second. Okay, I can't put right. Okay. Now x2 is my pen is gone. This is my x2. Angle is theta.
Angle is
Alpha minus theta, yes. So
yes,
x2 will be sine
L
alpha
sine,
minus theta.
yes ma'am, yes.
And z2 will be cos, right?
L cos.
z2, yes, cos. Now solve it first. Sin alpha cos theta minus now we have L sin alpha is cos x1, so this is x1 cos theta minus z1 sin theta. But still we are doing some mistake, I think. Here minus should not come. Okay, once again. This is a positive quadrant, this is positive, everything is positive here, right? L has also not changed, sign, angles we have taken care.
Use first and fourth quadrant, then minus will be reduced.
First and fourth, that's how it has been done in the course. That is okay. Like that we can solve, but Sandeep has this doubt that if we will take the absolute direction of the axis, then it is not coming.
Okay, but for this equation,
This whole is alpha, this is 90 minus alpha, alpha minus theta.
Ma'am, it is okay, ma'am. Till now it is okay, and as we have taken angle from the z axis, so till now it is okay, ma'am. Because we have taken angle from the z axis, not from the x axis.
That is fine, but here the matrix should not change. Matrix should come. If we will see, we will get cos theta and minus sin theta. You are getting?
Yes, ma'am.
Whatever be the direction of axis, however you draw, if you will take this one, it will come like cos theta 0 minus sin theta 0 1 0, and here it will come sin theta 0 cos theta, I think.
Yes, ma'am. It is correct, ma'am. It is correct. What we got is correct. Because I am telling, ma'am, please write that rotation, clockwise rotation matrix about z axis, then it is matching correctly, ma'am. As when we are
Okay.
interpolating also now, then also it is matching. So this
Okay, you want me to
derivation is
write
correct.
the Z1.
Yes, ma'am. Yes, ma'am.
So you are
When we
telling
are
that
rotating,
answer given is wrong.
yes, sir. Yes, ma'am. None of the answer is matching, ma'am.
Okay,
So it
it
is
may be
entirely
possible.
wrong.
It may be possible.
Yes,
I'm
ma'am.
not denying. Answer may be wrong. Now, what is this one? L sine L cos L sine alpha. This is this correct? Cos alpha sine alpha. This is x1, right? L sine alpha is x1. L cos alpha is z1. Okay, this is correct. Now for this we have got z1 cos theta, x1 sin theta. Okay. This we have got according to Sandeep's. Now the one which is given for around z. So
Yes,
it
ma'am. Around
is
that you right, sir. It will match exactly.
maybe they have just
This
changed
is
the.
anti-clockwise, ma'am. This is anti-clockwise. So for clockwise, for x sin theta will be positive.
This is anti-clockwise. This is how they have
Yes,
written
ma'am.
in course.
Yes, ma'am. For clockwise, sin theta should be positive. For cos theta, then sin theta 0.
Cos thetas
Clockwise,
are, this is positive, right? Okay.
yes,
This
ma'am.
is minus cos
Yes,
theta,
ma'am.
then
Yes,
0 0 1.
yes, ma'am. And here we can see, ma'am, when we are rotating about z-axis now, so whatever is happening to uh, our x coordinate, because after z, the next axis is x-axis in the cyclic rotation. So
Okay.
x cos theta, then y sin theta. So similarly, when we are rotating about y-axis, then whatever had happened to our x coordinate should exactly happen to the uh, z coordinate, because we are now rotating about y axis. So after y, the next axis comes z axis.
Okay, you are
So
telling that x is
yes,
common in both of them, so nothing will, no change should happen to x.
uh, no, ma'am. About z axis rotation, when we rotated about z axis,
Hmm.
then actually the matrix which came for came actually the x axis was transformed to x cos theta plus y sin theta.
Let me check. Let me check. X axis was transformed to
uh, x
x1 cos theta
axis
plus
was
y1
transformed
sin
about z
theta.
axis rotation. So similar thing will happen about when we are rotating about y axis, x1 cos theta plus sin theta. So now when we are rotating about y axis, then
They have written like minus plus. Okay.
yes, ma'am.
So you
So
are telling ki here it should be x1 cos
now
theta plus
now
z1.
now now x2 will be replaced by uh, x2 will be replaced by z, and now
No,
our x1 will be
y2.
replaced by, yes, ma'am. Yes, ma'am.
y2 will be replaced by z.
No, not y2, ma'am. Because when we are rotating now, when we are rotating about z axis, then after z, z axis is affecting the x axis. Z
Z
axis rotation is
axis is
affecting
affecting x axis. Okay.
x-axis. Similarly, when we are rotating about y-axis, then y-axis is going to affect z-axis in the same fashion as when the z-axis affected our x-axis. After z comes x, so similarly after y should come z. So when we are rotating about y-axis, then it
Okay.
will affect the z-axis in the same fashion as the z-axis rotation was affecting
Affected by
x-axis.
x axis. Okay. I
Yes,
got your
yes,
point. So you are telling this should be the answer.
Yes, ma'am. And so when we are replacing Z2 now, so Z2,
Yes.
our S2 will be our the earlier the old the Z axis rotation
Hmm.
was X2.
Yes.
Now it will be Z2. Now it will be Z2. So this Z2 is matching with our this our actual.
If we will replace this by Z2,
Yes, ma'am.
then
X2 for X2 we have to replace Z2 for X2. The X2 what we have written ma'am, in blue color,
no, this
that
is
we have to
for
replace.
X1. X1 is okay. Sorry, let me write here.
X, yes, ma'am. Yeah. Just write Z2
Is
Z2
X2?
equal
What will
to
be X2?
not ma'am. You write for Z2.
Okay,
Write for Z2. Z2 is equal to Z1 cos theta
Z1 cos theta.
plus X1 sin theta.
This is what we got for.
Yes, ma'am. Yes, ma'am.
Okay,
So here we can see the pattern between X2 and Z2
X2
because
and
when we
Z2.
rotate.
Okay, okay, I got your point,
Yes, ma'am.
Sandeep. Hmm.
Yes, ma'am. Yes, ma'am.
So, okay, maybe the answer given is wrong because they have
Yes, ma'am.
simply in place of x in place of y as done in the class, they have replaced it simply by z,
Yes, ma'am. Yes, ma'am.
and they have solved, because when I did like that I got the answer as answer A.
Yes, ma'am. Yes, ma'am.
So did they release the solution?
They have released the solution and they have given answer answer A only. A they have released.
Maybe because they also, because the answers are also prepared by some TA. I
Yes,
don't
ma'am.
prepare the answer, so I don't know how did they proceed the solution, which coordinates they have taken. So the answer which was given is A. So when I solved, I also took like this as done in the class. So I got the answer matching XZ, and here I took Y.
Yes, and it is not possible. It is not possible
When
because
it is
this is
like
a right
this.
hand screw rule. It is violating right hand screw rule
Yeah,
because we cannot
the
take.
coordinate itself is wrong, you are telling. Okay, I got your
Yes,
point.
ma'am. Yes, ma'am.
Hmm.
Yes.
Maybe, but if somewhere this question is coming na, in some entrance exam or somewhere, they will give you the coordinate. They will draw the coordinate there, the system. So there won't be such confusion.
Yes. So for changing the answer of this question because none of the option is matching.
Hmm.
So
Uh,
for
I
this
I don't know whether they can change the answer or not.
yes,
I
ma'am. Yes,
will.
ma'am. In other courses they are oftenly changing because it is a common phenomena. Often mistakes happen.
Okay, then
So
I
yeah.
will talk to someone who is preparing the answers.
Yes, ma'am. Yes.
And then I'll let you know, and I'll put it in the discussion forum as well.
Okay, ma'am. Okay, ma'am.
Okay.
Thanks.
Yeah.
Okay.
So let's see the next one. So none of them are matching really. B1 is not the same. What we got? Oh no. Cos minus sine, sine cos. B1 is not the same.
B is matching, ma'am. B is matching.
B is
B is
matching,
matching.
right? B is matching, no?
B is matching. B is matching. So an option should be changed.
Yeah. Answer should be changed. Okay.
Yes.
Because
Yes.
these answers are also given by some TA only, so maybe they also
Yes,
can make mistake. Not a problem.
yes.
Okay. Now let's move to next one. See, in this one they have given the system. This is the correct coordinate system which they have given.
Yes, ma'am. Yes.
Okay. Now consider the CO3 minus ion The 3 oxygens are designated 1, 2 and 3. The C atom is designated 4. Taking the pz orbital and 3 oxygen atom as the basis, pz1, 2 and 3, and transformation matrix as this one, it represents what symmetry operations. Okay. So did you do?
Yes, ma'am, I did.
Okay.
That is.
Okay. The other student, Bhagat, did you do it?
Yes, madam.
Did you submit the assignment already?
Yes.
Okay, great. So let's start with the first option is C3Z. Now C3Z when we will do. So what shall I write in short? Okay, let me draw for one. This is one oxygen, this is other, this is 3, this is 1, this is 2, and the lobes are also mentioned here. Okay. Now we will do C3 clockwise. Okay. So how the things will change?
They will interchange position, ma'am. 2 will come in place
They
of.
will just change the position and lobes
Yes.
will not interchange. Okay.
Yes, ma'am.
So
Yes.
PZ1 will become PZ.
PZ3.
Okay. So instead of, I am writing, instead of PZ1, PZ2 will come.
Yes,
Instead
ma'am.
of
Clockwise direction we
PZ2,
are taking positive now. Clockwise direction positive.
yes, this one, and instead of PZ3, PZ1 will come. So what will be the matrix looking like? This is the basis, PZ1, PZ2, PZ3. Now write the transformed one. PZ1, instead of PZ1, what came? PZ2?
Yes, ma'am. Yes, ma'am.
Okay. So let me change this. It came PZ2. PZ2 के जगह what we got? PZ3
3.
and remaining PZ1. Okay. So when 1 is becoming 2, so Y should have here, the second one should have a positive, not Y. PZ2 should be 1, others should be 0, because there is no mixing. When you will multiply,
Yes.
PZ1 into 0 plus PZ2 into 1 plus PZ3 into 0, it will give you PZ2. That's fine.
Yes, ma'am. Yes.
Now similarly for PZ2, how it got transformed? Yes.
Madam, what is the meaning of basis?
So basis is something on which you are applying the transformation operations.
Okay, madam.
Okay. So here we are not changing the x and y. We are doing the operations with respect to these p orbitals of the oxygen atom. So we have to consider the the orbitals with their lobes, positive lobe and negative lobe. Okay. So how this PZ2 will change? PZ2 is becoming PZ3. So you know this column is for pz1, this column is for pz2, this column is for pz3. Okay. Now here also similarly, this is after transformation. The columns are representing after transformation and the rows are representing before transformation. So now we have to check how pz2 is transforming. Now we have already seen that pz2 is becoming pz3. So we will go in the row of pz2, this row, and we will mark 1 for pz3 column, because 2 is becoming 3 and others will go to 0 because there is no mixing. Okay. Now similarly pz3 is getting transformed to pz1. Now we will go in the row of pz3, this row, third row, and we will mark pz1 ban raha hai, तो we will mark 1 here and then others will go to 0. Now you ignore this one, and now you do the multiplication of these two matrix on the left hand side and you will get this right hand side matrix. Okay. Both of you okay?
Yes, madam.
Okay, fine. Now what was the second option? So is this matrix, this is our matrix for C3 clockwise. So is this the same as the given one?
No, ma'am. It is
No?
different. No, ma'am.
Even if you will do for anti-clockwise, it will not be same. Okay. Now second option, C2y. Now we have to put a C2 along the y-axis. Okay, so let me draw this one. This is carbon. This is y-axis along which I have to put C2. Okay, so C2y, what it will change?
Position of 1 and 2 will be interchanged and position of 3 will remain same.
Okay, and what else?
And also the sign of lobes will change.
Yes, that is important here. Now here is my axis. Axis is passing through carbon atom and third oxygen atom. Okay, so it is flipping. Flip होने से pz2 will go to this side. So here we are getting pz2, and after flipping the lobes will change. Down, if you are considering this dark part down, it will come up. Okay, and similarly here it will be pz1 and down part will come up. And what will happen to this? Same thing, because this oxygen, third oxygen atom, is not changing its place but still it is rotating, and since the lobes were aligned along the z-axis, it has flipped now. The atom is rotating but not changing its place, rotating on its own axis, so the lobes will get changed. Okay. So what will happen? All three orbitals have changed their sign, we can say, and pz1 and pz2 got exchanged. Okay, so if I will write the sign change as negative, so pz1 is becoming minus pz2, pz2 is becoming minus pz1, and pz3, it is not changing to any other place, so it is remaining pz3, but it is changing the sign, so I am writing it as a negative one. Okay, now we can write the matrix. First is pz1, this is basis, I am writing basis first, pz3, and now I will write the answer which we got. Like after transformation, what happened? pz1 became minus pz2, so it became minus pz2, pz2 it became minus pz1, minus pz1, pz3 it became minus pz3. Now can you write the matrix? What will be first column, first row?
It is 0 minus 1 0.
0 minus 1 0, because 1 is getting transformed into 2, so second column will be 1, and now it is getting transformed with lobe sign change, so we have written it as minus 1. Now similarly z2 is getting transformed to z1, so this will be minus 1 0 0, and this will be 0 0 minus 1 itself, because it is not changing its position. Okay, so is this one matching with the given,
No, ma'am.
the one given in the question? No.
No, no, no.
Okay, then third is sigma h, x and y. So this one is what? Molecular plane.
Yes.
So in this what will happen?
All will remain at their own position, but the lobes will change sign.
Yes, the lobes will change sign. So this is lobe change sign to down part came up. This is pz1, this is pz3, and this one is pz2. Okay, because reflection along the xy plane. So what will be the matrix?
It will be a diagonal matrix with, but the all the diagonal elements will be minus 1, and other
Yes,
elements will be 0.
it will be remaining same with a minus sign. So the matrix will be minus 1 0 0 0 minus 1 0 0 0 minus 1. Okay, so this is also not the one asked in question, right? So let's see, D must be the answer then. Let's see, T is sigma V xy. Now this is y, this is x, this is I am drawing with before transformation, because I will have to go back to the last slide otherwise. Now where is the plane?
It is YZ plane there.
It is YZ.
YZ.
Sorry, yeah, I'm sorry. This is okay. So Y and Z means this plane. This plane. Okay.
Yes.
So after transformation, sigma V Y Z. Simply what will happen?
P1 and P2 will change places without change of sign, and
Without
also
change of
PZ
sign,
will,
yes.
yes, and
So
also
this
PZ
will
will
be
not change.
PZ2. This will be PZ1. So this one is the difference when we do axis and when we do plane transformation. With axis, lobe sign also got changed, but with plane, since it is simply reflection, it is not getting changed. This is PZ3. Okay, so how will the matrix be looking like? Now PZ1 became, okay, I wrote wrong, right? This is 2. PZ1 became PZ2 without change of sign. PZ2 became PZ1 without change of sign, and PZ3 remained PZ3. Okay. Now this one will be Z became 1 became 2. So here it should be 1, 0 and 0. Then 2 became 1. So here it should be 1, 0, 0. And 3 remained 3. So here it should be 1, 0 and 0. Okay. This is the answer? Yes.
Yes, ma'am.
Yes, this is the answer. So D is correct. Okay. Now, next one. For the same figure as in previous question, the transformation matrix for S3Z is S3Z. So, C3 plus sigma XY, that is molecular plane. Okay. So, we have seen what was the result after C3. Okay. This was the result after C3. Shall I draw the same?
Yes, ma'am.
Okay. Let me draw
It is
the
okay, ma'am. We
Okay.
can multiply those C3 and sigma H. No?
No,
Those
it's
two
fine.
matrices we can.
Yeah, it's fine, but let me draw. There may be other students also watching, so let me draw for them. So PZ1, this is C3, right? So this is PZ2 and this is PZ3. This is after C3. Now if we will apply sigma xy, so these things will remain at their own place and they will change. The lobes will get changed.
PZ1 will change their position, reflection, and PZ2 and PZ3 will remain at their same place.
Why? The lobes will change, right? All of the
Yes,
lobes
yes.
will change. Because the plane is molecular plane. This is the plane, and these things are up and down. Okay.
And this is planar molecule. All C and all oxygens are in the same plane.
Yes, they are all in the same plane, and this is that plane. This is the molecular plane. All
Yeah, I
the
got it.
all the four
And
atoms are in the xy plane. Okay.
then, ma'am, all lobes will change their sign.
Yes, all will change. Position of atoms will not change. Just the
Yes,
sign
yes,
of lobe will
yes,
change. Okay.
yes, yes, yes.
So we got. So ultimately, what we got from here, initial we had, let me write the initial, pz1. Here we had pz1, right? Initially, before any transformation, it became minus pz2. pz2 became minus pz3, and pz3, this became minus pz1. Both of you agree with this?
नहीं
Yes,
समझ में
yes,
आया.
नहीं समझ
yes.
आया? सी इनिशियली जो ओरिजिनल फिगर क्वेश्चन में दिया है, दैट इज हियर वी हैव, ऐसा है लोब्स, एंड हियर इट इज रिटन pz1.
Okay.
ओके, लेट मी ड्रॉ हियर इटसेल्फ. ये ऑक्सीजन एटम, उसके लोब्स ऐसे दिए हुए हैं, एंड दैट इज रिटन pz1. यहाँ पे ये ऑक्सीजन एटम, उसके लोब्स ऐसे दिए हुए हैं, दैट इज गिवन pz3, एंड दिस वन इज pz2. ओके, जो रेड कलर से आई हैव ड्रॉन, दैट इज ओरिजिनल गिवन इन द क्वेश्चन, ओरिजिनल कॉन्फ़िगरेशन. ओके, नाउ सी दिस वन. This is after C3. This is after C3.
Okay.
And after C3 we have applied sigma xy because हमें S3Z apply करना है. S3Z means C3Z and then perpendicular.
sigma xy.
Yes, sigma xy. So that's what we have done. C3 apply किया, then this is the configuration which we got. Okay.
Okay.
देन सिग्मा एक्स वाई अप्लाई किया. सो व्हाट सिग्मा डिड, सिग्मा ने पोजीशन चेंज नहीं किया किसी एटम का, बिकॉज सिग्मा एक्स वाई इज द मोलिकुलर प्लेन, सो इट जस्ट रिफ्लेक्टेड द लोब्स. ओके, सो pz3 here, which was pz3 after c3, so it remained at its own position, but उसके lobes change हो गए. So suppose this was positive, this was negative. Now positive went up, negative came down. Okay,
Okay.
so similar thing happened with pz2 and pz1 as well. Pz after c3, pz2 was at this place, and then it remained at this place, but lobe sign got changed. Okay, pz1, ओरिजिनल क्वेश्चन में pz1 यहाँ था, देन वी अप्लाइड c3, सो फ्रॉम it came here 120 degree rotation, and then after this we applied sigma xy, so lobes got changed to like this. ये डार्क ऊपर चला गया, लाइट वाला नीचे. ओके,
Okay.
यू गॉट दिस नाउ?
Yes, ma'am.
So now we are comparing with what this is, two transformation combined in one. S3 means two transformations, C3 and sigma. So this is original and this is after S3. Okay, original में यहाँ पे pz1 था, this place is pz1. What it became, it became the place of atom got changed, pz1 became pz2, plus the sign also got changed. So pz1 became pz2 and the sign of lobes got reflected, so उसके लिए I have written negative. Got it?
Yes, ma'am.
Okay, similarly pz2, our pz2 was here originally in the original configuration given in question. Now instead of pz2 we got pz3, and then again sign, lobe sign changed, so this is minus pz3, and pz3 was here, but now we have pz1 in place of pz3 with lobe sign changed, so it is pz1. So if you will write like this now, it will be easier for you to write the matrix. So let me write this again. I will so pz1 became pz2 with negative sign, pz2 became pz3 with negative sign, pz3 became pz1 with negative sign. Okay, so matrix will
Yes.
be pz1. This is I am writing the original, this is the basis. जो भी लेफ्ट हैंड साइड
Okay,
लिखा
ma'am.
है, दिस इज द बेसिस, एंड आफ्टर ट्रांसफॉर्मेशन व्हाट pz1 became pz2, so this is minus pz2, pz2 के लिए pz3, and pz3 became pz1, so minus pz1. This is after s3. This is original configuration. Now can you tell the matrix?
Yes, ma'am. 0 minus 1 0, 0 0 minus 1, and minus
0
1 0 0.
minus 1 0, 0
0
0
0 minus
minus
1,
1 minus
and
1
minus 1 0 0
0 0.
0 0.
So now is this matching?
Yes.
Answer D. Isn't it? Is this correct?
Answer D. Yes. No, madam, but answer is C. But answer given here is C is correct.
Answer given. Okay. Okay, so what I have done is, what I took here rotation for C3, what I have took, this is clockwise rotation, right? If you will take anti-clockwise, so actually C31 means I also had confusion in this earlier, but when I checked, it is anti-clockwise. When you say apply C3, we have to apply anti-clockwise, rotation by 240 degree, that is anti-clockwise. Okay. When it is C32, then you have to apply by 120 degree rotation, that is clockwise. Okay, this I have verified. This is given everywhere in books also and on internet also. So
Yes, madam. Always apply anti-clockwise rotation.
also always we have to apply, if not mentioned, we have to apply anti-clockwise. So
Okay,
now
madam.
if we will apply anti-clockwise, I think we will get the answer in this question. Now anti-clockwise में क्या होगा?
Now, I also had applied that clockwise rotation and it got wrong.
Yeah. Initially, like, everyone will think that it is clockwise, we should apply clockwise, but so here we had pz1, so here it will come pz3, pz1 will go here, and pz2 will come here. Now then sigma plane. Now can you guys write the matrix fast? pz1 became pz3, 2 became pz1, and 3 became pz2. Okay, so matrices will be 0 0 minus 1 minus 1 0 0 0 minus 1 0. This answer is which one? C. C is the correct one given, right? C. Okay, clear both of you?
मैडम यहाँ पर माइनस क्यों नहीं है?
Because
Z1 will go
lobes
minus.
got change, lobes change their sign.
तो ओनली रोटेशन में भी लोब्स चेंज हो जाएगा?
यस, रोटेशन में होगा, रिफ्लेक्शन में नहीं होगा. अगर यहाँ पे हम रिफ्लेक्शन अगर इस प्लेन में लगाओगे तो नहीं होगा, पर व्हेन यू आर पुट
नहीं हम ये पूछ रहे हैं आप
दिस इज
रोटेशन एंड
S3.
रिफ्लेक्शन दोनों.
दिस इज टोटल S3 रोटेशन
ओके
बाय
हाँ,
C3
ठीक
एंड देन
है.
सिग्मा. ठीक है.
ओके देन ओके.
हाँ. Okay, next one is for a D2H molecule, consider the principal axis to be z direction using the unit vectors along the three Cartesian axes as basis. Now here basis is not the atoms or not the orbitals. Here the basis is XYZ. Our Cartesian axis is the basis. The resultant symmetry operation for sigma xy dot c to x will be. Can we do this? शॉर्टकट से कैसे करेंगे इसे?
So matrix we can draw.
Yes. So
Matrix
sigma xy. Let me. What will be the matrix? सिग्मा एक्स वाई में क्या चेंज नहीं होगा?
X and Y both will not change. But
यस.
Okay, so x and y will not change, this will change. C to x, इसमें क्या चेंज होगा?
it is about X.
Y
so
Z.
Y and Z.
Yes.
Will interchange twice.
Y and z will change, x won't change. Okay, now if you will multiply, what will happen? 1, since it is a diagonal matrix, I can simply multiply the diagonal elements. 1 into 1, 1 minus 1.
Ma'am, when we are applying C2X now, then Y should become Z. then Z should become Y because C2x we are applying now. So Y should,
C2x.
because angular rotation by 180 degree. So about x axis we are rotating. So
I no, but here we have to do according to this D2H molecule, which is planar. Okay, let me write according to this. So D2 D2H.
it is okay, ma'am. Okay, ma'am. Axis will remain same, but the sign will change because
Yes.
when we are holding
See,
the x-axis and
if
if we
this
are
is
rotating the x-axis by 90 degree, that is 180 degree, then whatever was y coordinate that will become minus y, and whatever was z top up it will come down. So
yes,
it is okay,
because
ma'am.
this is okay, right? Now you got it.
Yes, ma'am. Yes.
So this is x. So we are applying here. This will come here. This will go there. After C2, so suppose this is 1, this is 2, this is 3, this is 4. So after C2 x, these two will be there. Okay. Sandeep?
Yes, ma'am. Entire axis will change, ma'am. Yes.
Yeah.
It will come negative.
So on multiplying, this is 1 minus 1 is minus 1. Minus 1 into minus 1, it is 1.
Yes,
Now
ma'am.
what is this? Since only 1 is changing, 2 are not changing and only 1 is changing, so this is some plane. This is some plane, okay? And now which is not
Sigma
changing,
ZX.
1 and x and z, so it is
Yes.
xz plane. Simply like this. But if you will do by taking example, it will be easier in such questions because they have specially mentioned that consider a D2H molecule. Then better to consider some molecule, easy molecule, and do like this. So
Ma'am, I actually tried by taking example, but some confusion was coming because there when we are rotating about x-axis, na, like you rotated the atom
yes,
along the line 1 2, then
yes,
upper half of the atom will become lower half.
yes, that is
So
correct.
so that confusion is coming because
No, but we here this is because we are taking basis as the Cartesian axis. Here atoms are not basis. If atoms would have been the basis, after rotation it will be, we will write minus 1. Okay.
yes,
So suppose here this atom, if this is only one atom, suppose this is some atom with positive lobe and negative lobe. Okay, here also some same atom with positive lobe and negative lobe. So after C2, this will become like this. Okay. In all this, for example, this hydrogen atom, there no, it has only one s. Nitrogen, suppose it has p orbitals, their lobes will get changed like this. But here the basis is not the atoms, the basis is this axis, this axis. So after C2x, what will happen? This will be x, this will be y, minus हो गया, and z is this side, it will go that side. This is minus हो गया. Okay. So that's why I'm writing matrix 1 minus 1 minus 1. Is it fine? Shall I move to the next one?
Yes, ma'am. Yes.
Yeah. Okay, so the cyclic group.
C3.
Yes, C3. This has been discussed in the class, right?
Yes, ma'am. Yes.
Now C3 is the answer for cyclic group. The element should be in order like this: x, x square, x cube, x4, like that. Okay. So suppose we are considering C3. C3, the symmetry elements are E and C3 itself, and since C3 is there means C3 1 is there, so there should be C3 2. C3 comes with two operations. This is clockwise, anti-clockwise. So if you will consider this one as x, E can be written as C33. Okay, and this can be written as x square, then this will be x cube. So we have x, x square, x cube. All three elements are like that. So that's why this one is a cyclic group. Now D3. What about this one?
It's not cyclic, ma'am.
D4.
D4 also not cyclic.
Ma'am, but D3 may be cyclic, no?
Let's see what
Because
are
it
the
has
elements.
E,
E, C3,
E, Cn,
C3,
and
3C2.
3C2, yeah, perpendicular to C3.
Yes, this is D3 group.
Yes.
Now if you will write this as C33, how will you write this one in terms of x? You cannot write, right?
Okay, got it, madam.
C3 will also be like C31 and C32 still, but this one is remaining, right? This is not forming like this series x, x square, x cube, like that. So this is also not a cyclic one. Similarly, you can try others. Okay, so next one, a group of order 4 is necessarily cyclic, necessarily acyclic, can be either cyclic or acyclic, and is always commutative.
C number.
How will you say that?
Can be either cyclic or acyclic.
Why are you saying
And
like that?
because there is a possibility, I have C here, D3 and C3 groups.
D3
And C3,
order should be 4, group of order 4.
yeah, C3, sorry, D3 have an order 4, E, C3, and sorry, I don't know.
Will this be?
C2, yes,
Now what elements are there in C4?
E, C41, C42, and C43.
That's all, right? So this is
Yes,
x, this is x square, x cube, and this is x to the power 4, C44. So this is an example of cyclic one. Okay. So if it is cyclic, can you write the multiplication table for this one? This is C4. E, C4, C4 square, C4 cube. E, C4, C4 square, C4 cube. What will be the first row and first column?
same as it is.
Same. So because we are doing operation with respect to E, E dot E will be E. E dot C4 will be C4. E dot C4 square will be C4 square. This is C4 cube. Similarly, C4. So now E dot, this is written first. So this is first, this is second. Now we have to read as E dot C4. This will be C4. E dot C4 square. This is C4 square. E dot C4 cube. C4 cube. Now C4 dot C4.
C42.
C4 2. Now C4 dot C4 2.
C4.
C4 3.
3.
C4 dot C4 3.
E.
E.
E हो जाएगा.
E हो जाएगा, right? C4 4 will be E. Now C4 2 dot C4.
C4 3.
C4 3. So all the elements are coming from within the group itself. So it is a group. What operation is this? What property of the group is this?
Cyclic group. Cyclic.
No. If I am doing any operation, for example C4 cube dot C4, and the answer which is coming as one of the elements from the group. So what property is this?
Transformation.
No, this is called closure property. Closure means closure is like close. Everything is close. Whatever answer you are getting is within the group itself, not from anything outside. Now C4 square dot C4 square.
E.
It will be C4 4, which is E. Now this one C4 square dot C4 cube.
C4 1. C4 1. C4 5. So C4 5 is C4.
1. Okay. C4. Now this one E. This is again C4. And this one
C4 square.
C4 square. So this is a cyclic. You can see the elements are also coming one by one in diagonal. C4 cube, C4 cube, C4 cube. So this is a signature of the cyclic group. Okay, now let's see C2V.
Madam?
Yeah.
आप स्टार्टिंग में बता रहे थे ना, जो कॉलम जो होता है वो क्या बोल रहे थे, वो रिप्रेजेंट जो हमारा आफ्टर जो हमारा प्रॉपर्टी है उसको रिप्रेजेंट करता है. रो जो है बिफोर का रिप्रेजेंट करता है, ऐसा कुछ बोल रहे थे ना?
हाँ, वो मैं तुम लोगों के लिए ऐसे ट्रिक बता रही थी जो यहाँ पे सॉल्व करने के लिए, कि ये जो है
क्या बता रहे थे? हाँ, वो
दिस
बता दीजिए
दिस
एक बार।
इज, ये हमारा बेसिस है ओरिजिनल। ओके, सो ओरिजिनल को यू कंसिडर एज रोज। सो सपोज तुम्हें पी
ओके।
जेड वन को ट्रांसफॉर्म करना है तो तुम फर्स्ट रो के साथ चेंज करोगे। ओके, तुम्हें पी जेड थ्री को ट्रांसफॉर्म करना है तो तुम थर्ड रो को चेंज करोगे जाके। ओके,
ठीक।
यही बता रही थी मैं। और किस में चेंज करना है, नाउ पी जेड थ्री को मुझे पी जेड टू में चेंज करना है, तो मैं पी जेड थ्री को चेंज करना है, सो आई विल गो इन द थर्ड रो एंड आई हैव टू चेंज इट इन टू पी जेड टू, तो आई विल गो इन द सेकेंड कॉलम। ओके,
ओके।
so other elements will be 0 in this case, because in this case there is no mixing. Mixing means mixing like this. Here, yes, here mixing means, see here we have elements like cos theta, sin theta. Okay, only one no mixing means the other two values will be 0 and only one value will have some value. Okay, only one column will have some value, but here two columns are having some value. It means it is a mixture of two coordinates. So z2, as here z2 is a mixture of two coordinates z1 and x1 both. So this is called mixing of coordinates. ओके, तो जहाँ पे मिक्सिंग नहीं हो रही है, लाइक इन दीज केसेस अदर सी ओनली वन कॉलम इज चेंजिंग, सो दिस इज कॉल्ड नो मिक्सिंग वी कैन से सिंपली, क्योंकि z1 is getting transformed into only one complete coordinate. यहाँ पे pz1 is not like some k times pz2 plus r times pz3, ऐसा कुछ नहीं हो रहा है यहाँ पे. You got my point?
Yes, madam.
Yeah. So one coordinate is getting transformed completely into the other coordinate. So such example is called no mixing of coordinates. No mixing of coordinates or basis. Basis is the correct word, because यहाँ पे pz1, pz2, these are not coordinate. Coordinate axis is x and y, Cartesian coordinate. pz1 and pz2 are our basis. Okay, now can we do this multiplication table for C2V also? Is now C2V E. What are the other elements? Let this be molecular plane. Okay, this one I am writing as molecular plane. Okay, okay, now E dot E will be E, C2 dot E will be C2, molecular plane dot E will be molecular plane, sigma V dot E will be sigma V. Now E dot C2, C2, E dot sigma V, sigma V, and E dot sigma V, this is it. Now C2 dot C2, 2 times C2 we will do, what we will get?
E.
E. Okay. Now sigma V, molecular plane, then C2.
Sigma V.
Let's do the easy one, all E ones. 2 times molecular plane you will get E, 2 times reflection when you will do E. Okay, now what else? Molecular plane, then C2, these two. You will get sigma V only. Suppose this. So this is molecular plane. After putting molecular plane, what I am getting? 1, 2. So this is 1, this is 2. And then I will put C2. So what I will get? H2, H1. Okay? So this is same as putting a sigma V plane here. Isn't it? So this will be sigma V. And same C2 times sigma Vm will be sigma V. Now next, these two, sigma V and then C2.
Sigma being molecular.
Yes. This opposite यहाँ से जाओ, यहाँ से opposite जाएंगे, you will get back this, right? इस side से.
Ma'am, whether all the operations are commutative here or
They are a group. So इस column में क्या नहीं, इस row में जो absent है, that will be the answer. Okay?
yes. Okay, ma'am. But in the previous case, we took sigma Vm in the next page. So, sigma V molecular plane, then multiplied by C2, it gave sigma V.
Yes. Now
Then
opposite you will do.
Yeah, opposite when we did
We will
sigma
get
V.
molecular plane, right?
Yes. C2 multiplied by molecular plane, then it gave sigma V.
Yes.
So here we have here we can see that both the operations are commutative. So whether such kind of operations are always existing or it is specific to this case.
No. Such kind of operations will not always exist.
Okay.
These are
Okay.
These are commuting, but it not for everything, because matrix
Okay.
multiplication, right? These transformations are like matrix multiplication, no? So if matrix row and the for first matrix number of column and for the second matrix number of rows should match. If they are matching, then we can do.
Okay, ma'am. But the basics are same now. Basics are same. So if our basis is XYZ only, then in that case matrix will always match.
Point groups, no, for whatever point groups they it will happen, but mathematically if we will do now for any other group,
Yes.
for any other mathematical group, x dot y and y dot x will not be always true.
Okay.
So for symmetry, if you will see with respect to symmetry, then that will form, because here only we are seeing, right, from molecular plane to sigma v you can get, and then from sigma v you can get back to molecular plane as well. Now this row, what is missing? C2. See here, first we have to apply sigma v, this is sigma v, and then you will apply a molecular plane which will be same as this. So this is a C2 operation. Now C2 dot sigma v, again a molecular plane, then molecular plane, then sigma v will give C2 again. Is this okay? Shall I move to next one?
Yes, ma'am. Yes.
Yeah. Next one is easy. Everyone did it, right? Someone left. Okay. Order of a group is H and order of one of its subgroup is H prime, then and H prime by H is P. So we have to write for P. P is a positive integer, or 1 by P is positive integer, P is even, or P is odd. So order of group is H. Now we have, from classes we have seen that order of group is integral multiple of order of subgroup. So how do I write it? H is equal to k times H prime. K is integer, like positive integer. Okay, now what is given here? H by H prime. Okay, so we will write it in terms of, it will be 1 by k H prime by H. Okay, so what is this? 1 by k is given as P. Since k is a positive integer, k I have written as positive integer. Now can you write P in terms of k?
And they have taken P equal to K, so
Yes.
that's why they have given
So
answer
we can write
1
like
by
this,
P.
right? 1
Yes,
by P.
yes, yes.
1 by P is a positive integer. So the answer is B. Okay. Next one. A and B are real positive numbers. Inverse of A minus B, B, A is. How do we find inverse of matrix?
That is a long method, ma'am. No? We have to take the adjoint matrix, then we have to divide adjoint matrix divided by determinant. So
Adjoint
that will
divided
take
by,
longer time. So we can simply multiply those two matrices if all the options, and if we can see that if
okay.
the product is 1, then we will see it is inverse.
But for 2 cross 2 matrix, there is an shortcut to find adjoint. Okay, what you have to do is, adjoint will be, suppose if you have a matrix like A11, A12, A21, A22. Okay, so what you have to do, you have to change the sign of these off diagonal elements. Okay, and then you have to interchange these two elements. The diagonal elements are there, right? So you have to interchange them. So answer will be, for this kind of matrix, adjoint will be after interchanging, I will get A22. This one I have to change sign. This one I have to change sign. This one is interchanged, A11. So this will be adjoint. So we can simply do that for this one.
Yes, ma'am.
A minus B, B minus A. BA. Now adjoint will be, interchange these two, AA, change sign of these two, B minus B, and determinant will be
A square plus B square.
A square minus of minus B dot minus dot B. So this will be plus B square. So this will be the inverse. Okay.
Ma'am, what the trick, what you just said now, this same trick they have applied in question number in third assignment. But this trick will not be applicable if there will be any complex number is there.
No.
Complex number is there.
Yes. This will not be yes, 2 cross, first it should be the 2 cross 2 matrix. For 3 you have to go by the long method only. Finding
But
the
even for
cofactor
but-
and all.
But even for the 2 cross 2 matrix, if the number is a complex number, then
Like this one.
Some yes ma'am. Yes ma'am. Yeah.
Like A, E, like this kind
Yes
of.
ma'am.
So this will not be applicable, yeah. For real numbers you can, because they have written here na, these are real numbers.
Yes ma'am. Okay.
So that's why I gave you this one. Okay? These
Ma'am,
are
in question number 6 you told now that for the group of order 4 order 4 yeah, it can be both cyclic
Yes,
as well
yes.
as non-cyclic. So,
Yes.
but in Cotton, ma'am, in Cotton I was searching because in Cotton they have not written in terms of like 2 examples. They have taken examples like A, B, and E, A, B, C, D, E, E.
Okay.
These are the elements they are taking, and based on that they are saying that it can have both cyclic and acyclic, but they have not explained how it can be both cyclic and acyclic.
Okay.
So
So you want me to explain A, B, C, D करके?
ABCD करके आपको yes ma'am. How it comes if it is for cyclic it can be okay. One they have derived, but one example they have not given. And
Okay.
so if not in this class, then in next class you can explain. Then also okay. And also, ma'am, we have another doubt regarding third assignment.
Okay. Third assignment. I
Question
will
number
discuss
8.
next week. Okay.
Huh?
Yeah, you can tell me.
Question number 8 and question number 3, ma'am. Just
One
see, ma'am,
second.
question number 8.
1 second.
Question number 8, ma'am.
Yeah, 1 second. I'm going there. Yes, this one.
Yes, ma'am. Yes, ma'am. Here, on taking adjoint, none of the value was coming because omega is there now. Omega is cube root of unity. So when we take adjoint of omega, that negative of omega means actually value of omega is -1 plus.
You don't need to
I.
take the value of omega here.
Yes, ma'am. But if we are just doing now by your method, then it will come answer, ma'am. It will come okay. But
Why do you need value of omega to get the cofactor? Even if you will do with the long method is finding the cofactors,
Yes,
finding the matrix of the cofactor, then transpose that matrix, and then multiply it with the reciprocal of determinant.
yes, ma'am.
So try to find it through the cofactor method. Maybe you will get it.
cofactor method I tried, ma'am, but omega value is there now. Means I just want to know whether omega is a because omega is a complex number now. It is a cube root of unity, cube root of unity,
Yes.
and omega we are writing omega
No,
as
don't write the full form of omega. Just take it as
okay,
omega only.
okay.
Huh.
Okay, ma'am. Okay, ma'am. And
Yes.
in question number three, ma'am. Question number three. Then it is okay. Question number eight, okay. Question number three.
Hmm.
I tried multiplying inverse with the original matrix, but never I was getting one. With
Okay.
all four, I multiplied. But here, when we are multiplying, then it should come. But none of the option was coming.
Okay. Let me see. Shall I do it now or shall I'll do it
Yes,
next
ma'am.
time maybe. Yeah.
Okay, just because here we can see, ma'am, just first row.
Yes.
If we are multiplying this first row with any of the first column,
Hmm.
then it is not giving one value. One value means it should give d value equal to d equal to a square plus b square plus
D
c
is
square plus
equals
d
to
square.
this one. Yes.
Yes, it should give, but this will only give this value equal to d
Okay.
when
Yes. There is no
it is the
negative here. There is no
yes,
negative.
no,
Hmm.
yes, ma'am, no negative is there,
Yes.
no negative.
Yes. Okay. Maybe there is some printing mistake in this one.
Yes, ma'am. So
Yeah.
this question number three.
There should be some negative. A minus IB. It should be there in some of the any
Yes,
one of the option.
yes,
Then
yes,
only you
ma'am.
will get all positive.
Yes, ma'am.
Hmm. Okay. So today's everything is fine, right? Week 2.
Okay, ma'am. Yes, everything is fine. Ma'am, I have a small question.
Yeah.
Group multiplication table और character table में क्या difference होता है?
Okay. Character table is actually I cannot explain right now what is character table. Multiplication table I can tell is multiplication table is derived from maths. Group theory from mathematical
Okay.
point of view, that is a group multiplication table that you can apply for any group, not only the symmetry group. Okay,
And character table is derived on the basis of
symmetry
experimental
points
result.
of group, and character table represents what all
The
the
property of
elements will undergo what transformation on applying any operation. Okay, this is mostly kind of same, but in character table it is with respect to all the symmetry elements, symmetry operations. Okay, group multiplication table
okay.
can be abstract, can be for anything. Group multiplication table you will find in maths book also, group theory chapter mein. Character table is specifically for symmetry point groups. Okay.
Okay, madam.
Okay. Then shall I close the session now?
Yes, ma'am. Thanks,
Yeah.
ma'am.
Yeah.
Thanks for
Okay.
the session, ma'am. Thanks.
Thank you. Thank you both of you.
Thank you.